Okay, this is homework 1.6. I'll be going over problems 45, 47, 49, 51, 53, 55, and 57. I'll be leaving the answers in the description if you just want to look at them. You don't need any instruction. But if you need any more help, you can ask me on Discord. I'll leave my Discord in the description as well. So, 45. Define oxidation and reduction in terms of A, electron transfer, and oxidation numbers. So in terms of electron transfer, when you oxidize something, that means that it's losing electrons. That means that in its original state, it has too many electrons and needs to give one of them up to get to its ideal stable state. And for reduction, that means that the original atom has too little electrons. So for example, if it has 7 and it needs to get to 8, it has a negative charge because then it needs to gain an electron to get to 8. And then in terms of oxidation numbers, first let's talk about what an oxidation number is. It's pretty much just the formal charge. So for example, with sodium is going to lose its it's going to lose its valence electron. And then for chlorine, it's going to gain a valence electron. So -1, +1. That corresponds to the charge. So positive means that it's losing electrons, and negative means that it's gaining electrons. I know, it's confusing. Same thing with permanganate. +1, +7, -2. And by the way, this is each oxygen is gaining 2. So there's 4, it's -8 if you count all the oxygens. Anyway, so this means that in terms of oxidation numbers, if you're oxidizing something, it becomes more positive. So with sodium, since you're oxidizing it, its oxidation number will be positive. But since you're reducing Cl, chlorine, it'll be a negative oxidation number because it is gaining electrons. Now, 47. Which region of the periodic table shown here contains the most readily oxidized elements? Which region contains the least readily oxidized? So again, when you oxidize something, that means that it is losing electrons. It means that it has one too many, and it needs to get rid of it to get to a full shell. So with the periodic table here, these elements have positive charges generally because, and I'm talking about those up to the third row generally, these usually have positive charges, which means that they want to give up their electrons. So therefore, metals, because metals are in this general area, metals are the most readily oxidized. That's why you kind of hear about metal oxidation. You don't really hear about carbon dioxide oxidation. That doesn't really happen. And then in terms of least oxidized, those are going to be the nonmetals because these need to gain electrons. These need to because if you look at the periodic table, they all have like either 6 or 7, meaning that they're closer to getting a full set by gaining electrons than losing them. So we say that they have negative charge, and that's the answer to 47. Okay, 49. I'll be going over the first 3. Determine the oxidation number for the indicated element in each of the following substances. So for this problem, I would recommend you pull out a periodic table so that it kind of helps you, because I would not expect you to memorize all of the charges of every single element at this point, although it would be nice if you did. But I would recommend doing that. And with that information, we can solve these problems. So for A, we need to find the charge of sulfur, or the oxidation number of sulfur in SO2. So for the periodic table, we know that oxygen has a -2 charge, and oxygen, because oxygen has 6 valence electrons, needs 2 more, so -2. And then we know that there are 2 oxygen atoms, so that's -4. -2 plus -2 is -4. So in order to match that and get to our ideal 0, we're going to have to add 4. So sulfur has a charge of +4. Now for carbon and COCl2, we know that chlorine from the periodic table has a -1 charge. Since it has 7 valence electrons and needs to get to 8, it needs to gain 1, so that's -1. Since there are 2 chlorines, it's going to be a -2. And then since oxygen, we know, is a -2 charge, it's going to be -2 again. And if you combine those together, that's -4. So in order to match that, carbon has to have a +4 charge. Now for the charge of manganese and permanganate, oxygen has a -2 charge, and multiplying that by 4, you'll get -8. And then potassium, as you can see, the periodic table only has 1 electron, so it'll give up that 1 electron. So it's going to have a +1. And if you add those together, you're going to get a -7 charge. So in order to get a 0 charge, you need to add 7. So you'll have +7. And again, you're just going to want to match. So again, with SO2, it's going to be +4, -4 equals 0. +4, -2 is 0. plus 1, plus 7, minus 8, that's 0 again. So that's what you want to get to. You want to get to 0, unless it's an ion. If it's an ion, you have to match the charge, but you're never going to have to worry about that, I don't think. Okay, 51. Which element is oxidized and which is reduced? I'll be going over parts A and B. So we know that elements in their natural form have a oxidation state of 0. So we're going to say that nitrogen has an oxidation state of 0 because it's in its N2 base form, so it's fine. And then say with H2, it's in its base form, so it's going to be 0. And then when we get to NH3, that's when we start to see some oxidation states. So we know that H3 is going to have a plus 3 charge because we see in nature that hydrogen usually has a plus 3, or hydrogen as by itself has a plus 1 charge. And since there's 3 of them, it'll be a plus 3. So in order to get to 0, we did have nitrogen having a minus 3 charge. So it's going to be minus 3 plus 3. And then we can see that since nitrogen has a negative charge, it's being reduced. And since hydrogen has a positive charge, it's being oxidized. So that's the answer. And then for part B, we know that iron nitrate has a negative charge. It has a minus 1 charge. And since there are 2 minus charges, we're going to say minus 2 here and plus 2 here. So iron has plus 2 oxidation states. And then aluminum, since it's by itself in its natural form, is going to have a oxidation state of 0. And then we look at the products, we're going to find that iron is in its natural state, 0. And we're going to find that aluminum has a positive charge, where it's plus 3. Because there's 3 nitrates, and as we know, nitrate has a minus 1 charge. So it's going to be minus 3. So from this, we can find that iron is being reduced into iron, its natural state. And then we'll find the aluminum is being oxidized, where it's losing electrons, and it'll become a alloy. So that's the answer. All right, next problem. Okay, 53. Write balanced molecular net ionic equations for the reactions of blah, 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 blah. So I just have the teacher's workbook here. If you need help, you can ask me. These questions are a little simple because we've done a lot of this before. But I think something that could trip a lot of you up is figuring out what is being oxidized and what is being reduced. So I would recommend just using a activity series or something of the sort to help you figure out what is being oxidized, what is being reduced. But just so you know, you're not going to be given this on the test. You're going to be expected to not memorize, but know some of them, some of the trends, what's on the top, what's on the bottom. So that's important to know. But feel free to use an activity series to help you out, because I know I would not have memorized all of this. So no judgments. All right, 55. Using the activity series, write balanced chemical equations for the following reactions. If no reaction occurs, simply write NR. So here I have the equation for A. So we have iron metal, which is in its base form, so it has a charge of 0. And copper nitrate. Copper here will have a negative charge. Sorry, it'll have a positive charge. So when you look at the activity series, you'll find that copper is going to want to be reduced into copper metal because it is higher up, and iron will be oxidized into iron nitrate. So yeah, that is A. If you need any help with any of these other problems, they're all the same logic. You look at the activity series, see what wants to be oxidized, what wants to be reduced, and then plan accordingly, and then just balance. But if there's any tricky things, don't be afraid to ask me. All right, next problem. And last problem, actually. Okay, the metal cadmium tends to form cadmium 2+ ions. The following observations are made. So if you put zinc metal with a cadmium chloride, cadmium metal is formed. So in a reaction with cadmium solution and zinc, cadmium metal is being formed. And then 2, if you put a strip of cadmium metal and nickel nitrate, nickel is being produced. So with this, we're expected to make a net ionic equation. So based off of 1, we know that zinc metal and cadmium ions react to form cadmium metal. That means cadmium is being reduced because the ions, which you have 2+ charge, they're being reduced to form a 0 charge. Therefore, the opposite happens to zinc, where zinc is at a 0 charge, but since cadmium is being reduced, zinc has to be oxidized to form zinc ions so that the equation can happen. All right, then for 2, the opposite happens, where cadmium is actually being oxidized so that nickel can be reduced. And that is just something that you can see in the observations. And then for B, what can you conclude about the position of cadmium? We know that cadmium is going to be above zinc. It's going to want to be reduced more than zinc because if you put them together, you're going to see cadmium metal. You're going to see cadmium ions from cadmium metal and zinc metal turn into zinc ions. You're going to see cadmium reduce so that zinc can be oxidized. So therefore, we see cadmium above zinc. And then you see the opposite. Nickel is going to be above cadmium because when you put nickel and cadmium together, nickel is going to usually reduce rather than cadmium. So there's kind of a hierarchy there. And then C, what experiments would you need to perform to locate more precisely the position? You should just do more and more metals. You should just do more and more things so you can further kind of trace where it is. Because with this, we only have 2 things. But if you add more, you can kind of more flesh it out. So yeah, that's all. All right, so that was homework 1.6. Enjoy your night. And again, feel free to ask me any questions.